Welcome to your comprehensive guide on Hooke's law, a crucial concept in physics that explains the relationship between force and spring extension. Hooke's law describes how springs and elastic materials behave when a force is applied. Understanding this is key to many mechanics problems. We'll be looking at three key terms: force, which is the weight causing the stretch; extension, the change in length; and the spring constant, which represents the stiffness of the material. The law itself is summed up in one simple but powerful equation. Force equals the spring constant multiplied by the extension, or F equals kx. Next, let's explore how you measure extension in a required practical setting. In the lab, you'll use a retort stand, a spring, and varying weights to measure how much the spring stretches. The first step is always to measure the natural length of the spring before any weights are added. After adding a weight, measure the new length. Extension is simply the new length minus the original length. Remember, it's the change in length, not the total length. Here's a pro tip for your lab work. Keep your ruler vertical and your eye level with the measurement to prevent parallax error, ensuring accurate results. Now let's see what happens when we plot your results on a graph. When plotting force on the y-axis against extension on the x-axis, the results initially form a straight line that passes through the origin. The gradient, or the slope of this straight line, is equal to the spring constant K. A steeper slope means a stiffer spring. Watch closely for the point where the line begins to curve. This is called the limit of proportionality, and beyond this point, Hooke's law no longer applies. Past the limit of proportionality, the object may become permanently deformed, exhibiting what we call plastic behavior. Let's put this all into practice with a classic exam question designed to test your knowledge of units and conversion. The problem: a spring is 5 centimeters long. A 100-gram mass is added, making it 7 centimeters long. Calculate the spring constant K in newtons per meter. First, find the force. The exam gave us mass in grams, so we must convert to kilograms. Then use the formula F equals mg, where g is 10 newtons per kilogram. Our force is 1.0 newton. Next, find the extension. The change in length is 2 centimeters. But the question asks for newtons per meter, so we must convert 2 centimeters to 0.02 meters. Now rearrange Hooke's law to K equals F divided by X. Substituting our converted numbers, we get K equals 1.0 newton divided by 0.02 meters, giving us a spring constant of 50 newtons per meter. Let's quickly recap the key takeaways from Hooke's law. Remember the fundamental rule: F equals Kx. Look for the straight line through the origin on the graph, and don't overstretch your springs. Final, and most important tip: always check your units. Force must be in newtons, and extension must be in meters for a correct K value.